In problem 6.49, you have a vehicle that's traveling at a constant speed of 20 meters per second. The initial and final speed are the same in this problem. You're going up a 3% incline, and what that means is that for every distance L that the vehicle travels, the height changes by 3%, 0.03 L. What you're asked to find is what the power is equal to. The power is equal to work divided by time. If you solve for work in this problem here, you find out that it's the potential energy minus the initial potential energy. So the final potential energy minus the initial potential energy plus the kinetic energy final minus the kinetic energy initially. So it's the change in potential energy plus the change in kinetic energy, or simply the total change in mechanical energy, all divided by time. Since the speed is unchanged, the initial speed and the final speed are the same, this term is zero. So the individual terms are not zero, but the difference between the two is zero. The final potential energy is mg times 0.03 times the height. If you assume that at the bottom of this hill, if you assume that corresponds to zero height, then this term is zero. And you have all of that over t. The next thing you can do is realize that what you have here is 0.03 times mg. This is the mass of the vehicle times the acceleration due to gravity, and you have L over t. Now this t right here is the same t that we had here, so all of these are the same t's. This is the time over which you're considering this work being done. That also means that if L is the total distance traveled and t is the time that it takes to get from here to there, that L over t is simply the velocity, or the speed of your vehicle. Distance over time. This will allow you to find the power, that's what the P stands for here, the power in watts, and then you can convert that over to horsepower by realizing that 1 horsepower is equal to 746 watts.